Renal fibrosis is the excess accumulation of extracellular matrix in the kidneys and is a common characteristic of chronic kidney disease, or CKD. In the case of CKD, it is an irreversible process. It is a consequence of the kidney's limited capacity to regenerate after injury and may result from various diseases, such as diabetes, HIV and obesity, or primary kidney injury. There are several pathways that lead to renal fibrosis. For this research, we will focus on the TGF-beta pathway, which stimulates renal fibrosis in different ways. In case of impact on the kidneys, angiotensin II and endothelin-1 are produced that stimulate the expression of TGF-beta. TGF-beta directly leads to the conversion of fibroblasts to myofibroblasts. Myofibroblasts are activated mesenchymal cells that increase stressed fiber forming. This leads to enlarged matrix production. Additionally, TGF-beta stimulates SMAD7, which results in overproduction of ECM. Moreover, TGF-beta stimulates SMAD3, which inhibits ECM degradation. SMAD3 also upregulates microRNA 21 and microRNA 192, but downregulates microRNA 29 and microRNA 200, thereby contributing to the progression of renal fibrosis. BMP-7 shows an antifibrotic role in chronic kidney disease. For instance, BMP-7 inactivates cells that produce ECM and increases ECM degradation. BMP-7 phosphorylates SMAD1, 5, and 8, which forms a complex with SMAD4 that can regulate gene transcription. This complex also induces SMAD7, an inhibitor for TGF-beta signaling in normal circumstances. But in the case of renal fibrosis, the expression of BMP-7 decreases. Therefore, the research question is provision of additional BMP-7 a possible treatment for renal fibrosis through the TGF-beta pathway? As BMP-7 and TGF-beta counteract, the hypothesis is that provision of additional BMP-7 can potentially decrease renal fibrosis. In order to test whether BMP-7 counteracts the pro-fibrotic effects of TGF-beta, mice models are used. The mice undergo unilateral ureteral obstruction, after which half of the mice is given a control vehicle treatment and the other half is given BMP-7 intraperitoneal. 8 days later, the kidneys are harvested. Sections of the kidney are prepared for immunohistochemical analysis using pus staining in order to determine the tubular damage. Other sections are treated with serious red stain to stain collagen, which makes it possible to quantify the amount of extracellular matrix. Finally, quantitative PCR is used as a further readout of BMP-7 pathways by finding the expression of the BMP target gene ID1 and BMP-7 microRNA.